I'm going to be presenting about API management along with Kurt Stam here. We're a couple of US-based Red Hatters here. So what we're going to do is I'm going to talk about API management, kind of what it's all about. Thank you. I'm going to talk about API management, what it's about from kind of a high level, talk about some of the concepts, and then I'm going to throw it over to Kurt, hopefully in about 10 minutes or so. And he's going to give more of a demo, kind of dive into the concepts a little bit more. So I work mostly on API Man, which is the upstream project for API management. It's a JBoss project. And Kurt's done a lot of the integration between API Man and Fabric8. So between the two of us, hopefully we know what we're talking about. Let's go ahead and get started. Okay, what is API management? Sensible first question to ask. The way I think about it is API management is applying governance policies to API requests at runtime. Okay, yeah, that bears some explanation, right? So what I'll do is start with a little bit of a discussion about what are microservices. I think this is a great sort of segue from the conversation we just had, right? Somebody had a question: what qualifies a camel route as a microservice, or anything else, right? We haven't really talked about that very much here, despite this being a microservice architecture day. So a microservice, again, I think we've answered that question very well just a few minutes ago. A microservice is a way of developing software, right? So it's an approach, it's a style, it's not a specific technology. So a microservice can be built in lots of different technologies. Fabric8 using any kind of runtime inside of a Docker container. So you could use JAX-RS, you could use just a standalone Java application and embed Jetty. You could have Wildfly Swarm. The options are endless. Everybody here who's a Java developer in particular knows the options for doing these things in Java in particular are endless, right? So in this diagram here, it's a very simple example of a sort of a naive or a starting point for your microservices architecture. You have some REST clients typically on the left-hand side here in this diagram. Got some services over here on the right, so I'm going to use services again. I'm going to use it like 15 times, so just get ready for that. Well, we got our APIs, our back-end APIs here on the right, and they're built, again, using whatever technology you want to use. And so we're just speaking REST between these two things. It's very simple. Each one of these boxes on the right, each one of these APIs, is a standalone microservice, again, using whatever technology you want, or a mix. One of them can be Swarm, another one can be Spring Boot, whatever. And so they all, a lot of times, have their own, certainly they have their own life cycle, they a lot of times have their own resources. Occasionally they might share resources, so you could have just a database that's just meant for your inventory API, but you might have one that is shared between a couple of different APIs. So that's all simple, it's really easy. You get to build this stuff, deploy it, developers are happy, runtime guys are happy, everything's good. Let's hit down. So the problem comes in when you start to have some requirements to these microservices that are shared, right? These are sort of non-business logic requirements. So my inventory API does inventory stuff. My products API does product stuff, right? It's very simple. But they all have this requirement of authentication, for example, right? We need to put basic authentication or OAuth or something like that in front of each one of our microservices. Well, all of a sudden, some of the benefits of microservices start to get in the way a little bit, right? Because they have their own lifecycle, which is great, but that also means they have their own lifecycle, which means that if I have to add some sort of functionality, common functionality like authentication, I have to do it for every single one of my microservices, and then I have to go through that deployment lifecycle. If I've got everything automated, that can mitigate that a little bit, right? I can write the code, build it into some sort of library that I can share across all my implementations. So these things can be mitigated. It's not the end of the world, especially if you're just doing something like basic auth. However, at some point, some terrible user, we all have terrible users, they're going to use too many of the resources, right? You've got some runaway user that's basically doing a denial of service attack on your services, and somebody from management says, hey, we've got to have rate limiting on this, right? So now we've got to go ahead and implement rate limiting for each one of our microservices. So again, not that big a deal. We could probably implement that without a ton of work, but these things are just going to keep coming up, right? So we're going to have these common bits of functionality that we need to support for each one of our services. This is where API management comes in. So what we do to this diagram is we stick something in between our clients and our backend services, right? So now I've got some clients, instead of contacting my backend services directly, they're going to go through what we call an API gateway, right? So pretty much every API management solution you look at is going to have some concept of this idea, some sort of API gateway that is the runtime that sits in between the clients and the APIs. And all it does is it proxies everything that comes into it. So you got all these HTTP requests coming in from your clients. They come into the gateway now, and the gateway figures out, oh, what are they calling, right? So there's some mapping that goes from the request information to some backend service that's really being invoked. So it figures that out. But then, and most importantly, and here's where we go back to sort of my sort of fundamental slide, and the takeaway from this, from my part of the presentation at least, is the application of policies at runtime to every request that comes through this gateway, right? So the gateway now says, okay, I've got a request for the products API. I'm going to figure out what policies should be applied for that particular backend service, and I'm going to go ahead and apply those policies. And so now it's the gateway that is talking to your LDAP server, or it's going out to your whatever kind of state sharing thing you're doing for rate limiting. And that's where all that code is executing, where the responsibility for doing all that work is. And what's really nice is your backend services now change less frequently, since you don't have to roll out new versions for this functionality. But also, they don't know anything about these things. So authentication, caching, rate limiting, all this stuff that we can do at a gateway keeps your microservices simple, right? So you can really focus on the business logic there and maintain them, the lifecycle of those things, and only release them when you have some sort of substantive business-related reason to do so. All right. Now, the question you might have is, okay, great, I've got these policies, they get applied at runtime for all these requests that come through, right? It's a high volume thing. Where does the configuration come from? And so for my part of this, I'm gonna hand wave this a little bit, but again, most API management solutions have some concept of this. We call it an API manager. The API manager, if the API gateway is the runtime bit of this, the thing that actually executes policies and does authentication and all that stuff for your services, the manager is what your developers would use in order to set up those configurations, right? They go into this, for us, for API Man, the API manager is a set of REST services, going after some sort of back-end storage where it keeps all this information, as well as a user interface. So you have developers who can access a UI, or they can access a set of REST services, and they use this layer here to set up the configurations separately for each of the services, or shared across multiple services. But that's what they use. That's the tool they use to say, okay, for the inventory API, I'm going to need authentication and rate limiting. For the products API, I'm going to need authentication and caching, what have you. So that's what the API manager does. And once a developer's actually gotten to the point where they've set everything up the way they want it, then all they have to do is publish it, click a button, all that stuff gets pushed into the API gateway, so that requests that come into that gateway, we have the policy information at that point that we need in order to apply them. Okay. So what kind of policies do we have? I've been talking about policies. What specifically? We've already mentioned security a little bit, mentioned rate limiting. Here's just a kind of a list. I'm not going to go through all of them, so maybe we can reclaim some of our lost time here. But security, OAuth 2, basic auth, etc. Limiting, we can do both rate limiting and quotas. And then, there's a bunch of other stuff that don't really fall into either of those two sort of primary use case categories for API management policies, which are things like caching, things like CORS. CORS is a very good example. If you have a back-end service that needs to be, like a REST API that needs to be called directly by some client-side UI, you have to enable CORS. Well, for API management, it's a simple matter of just sort of enabling that policy. It's basically flipping a switch, and all of a sudden, CORS support for your back-end service. So it's really nice. I have this last bullet point here on the right. It's just labeled custom. And I have that in green just so that I didn't forget about it. One of the nice differentiators, I think, for the API Man upstream project relative to other API management solutions is the ease with which you can design and build and deploy and use your own policies. So it's a very nice, I won't get into the details, but it's a very nice a plugin infrastructure that we have, especially if you're a Java developer, because all this stuff is written in Java, using very familiar Java tools. You can, it's just a matter of creating some Java classes that implement a specific API Man interface, package it up in a WAR, shove it into API Man, and you can start using your own policies, which is really nice, since out of the box, we're not going to have every single possible thing that enterprises might want. So I wanted to point that out. All right, quick summary, and I'm going to get it over to Kurt. I just sort of simplified this view a little bit here, but just to kind of reiterate the points. Left-hand side, right, we've got REST clients. REST clients are trying to access back-end services, back-end APIs. They're doing it by making HTTP REST calls oftentimes. We stick an API gateway in between them, right, so that all requests that go through that gateway, we have a chance, we have a crack at applying policies. The policy information, the policy configuration itself is produced by developers using the API manager UI and REST services, and then pushing that data into the gateway. So, API management in a nutshell. All right. So next slide is Kurt's first one. So come on up and.
All right. Thank you, Eric, for this great introduction into API management. My name is Kurt Stam. I live up on the North Shore in the Boston area. I used to live here in Brooklyn Heights, actually, and I used to kayak a lot, and especially the East River was one of my favorites. I don't know if you know the Hell's Gate is way up high. I understand why it's called the Hell's Gate, because the tides here are amazing, because it pools. It's not a river at all, actually. It's salt water. And the tides between the currents around Long Island and coming straight through the Verrazano Bridge cause amazing effects. So if you're out there with a little boat like a kayak, you understand why it's called Hell's Gate. I've been with the Red Hat for a little while, since 2006 when I worked on JBoss ESB. And one of the things I did was UDDI. I ran the Apache Judy project for a while, but thank God that's over now. And Kubernetes has absolved us from all these complications. API Man, cool. It's a product that's it's an upstream project, and I have worked on deploying it to Fabric8. So we've already talked about the green stuff, where the circles are the services, and the boxes are the pods, right? We've already established how that works. API in itself is an application with the UI, so that is actually one of the green circles, and you can have as many square boxes behind it as you want. Another green circle is a quick start that we will be deploying during the demo. And then there's this red stuff on top of it. So what is this red stuff? This red stuff is the gateway. Yeah, question. Sure. I'm a little bit too tall, I guess, for the microphone. I don't play basketball. Hopefully this is a little better. What is that red stuff? How many of you use an API manager right now? So there's not very many. For you who have not ever used an API manager, you probably use Apache HTTP to proxy your applications, right? So really that red stuff is, you could say, Apache HTTP, right? Where you can do some proxying, you use mod proxy and stuff to have external requests feed into your internal services. So that's really what that red box is, and that's called the API Man gateway. So even the gateway is implemented as a Kubernetes pod and service. So are you guys ready for a stupid cat video? So before you jump into the box, like this cat does, and not know where the eject button is, I'll really show you in the demo how this stuff works. So let me click this away. Here you go. So this is the Fabric8 console we've all seen before, and as you can see, there's the API Man management, and then there's the apiman gateway. So to get to the console, I have this up and running here. We're gonna have one more permutation of video, automated shell scripts, doing it and not working. I'm just gonna use Eric to do it for me. And hopefully, yeah, this is much better, I think. All right, so what we're going to do is we're going to deploy a quick start. We're going to import it into the apiman manager, and then we're going to publish it to the gateway. Yeah, so if you go to the second tab, the REST tab, we can here do the Maven local deploy task. So this is going to deploy a REST quick start application. So it's a little REST endpoint that we can hit. This is the last piece of text that's gonna be rolling over the screen. From then on, it's all in the UI. So it's packaging it up into a Docker image right now, and it will be publishing it to the running OpenShift 3 Kubernetes. Hopefully our session is still good. Yes, it is. Awesome. So if you go over to the console in the first tab, yeah, there you can see we have this quick start is deployed. All right, so in the apiman, we're going to now create a new organization. So apiman has this concept of, organizations that produce services and maybe other organizations that are consuming these services. So right now we're setting up an organization that is publishing a service out. So we're going to the service tab, and this little caret here allows you to go through a wizard where you can import services in your namespace. So you have access. You have one apiman per namespace, so you can import every service in that namespace. So we're gonna look for our quick start, finding it here. So we're going to click on add, and we're going to go through the motions to import it through this wizard. We're going to make it public. Public means that we're not actually going to set up contracts between two parties. We're going to do it very simple in the beginning. What we're going to do is we're going to just publish it to the gateway. It means that, you will be able to go through that red box to your internal service.
So, quick question.
Yes.
Where did it look for the service?
Excuse me?
Where is the service available? Where are you searching for the service?
In Kubernetes, so it talks to Kubernetes. It does a lookup in Kubernetes within your namespace.
Okay.
Yeah, and actually we annotate it. We've been working on annotations to annotate where the endpoint of your REST service is, because not always is it at the root. And we also annotate it where your description of your service is, so you can tell it what the Swagger endpoint is, or Waddle, or whatever definition language you are using.
So if you don't have Kubernetes, then where is it?
Yeah, so it's actually pluggable, so you can customize it. We have a couple, so in the upstream project, which I think is what you're asking about maybe, when you're not running in some kind of platform like Kubernetes or Fabric8, then we have a couple of different implementations of the sort of the search service, right, to find services to import. So you can implement your own if you have your own service registry of some kind. Sorry, service registry. Wouldn't be UDDI, obviously it'd be something else. But no, I mean, we could implement, and so going forward we'll have multiple implementations, probably UDDI and other service registries. Or you can build your own if you've got like a database someplace.
All right.
But you can always click the blue button, the service button, to create your own service. You don't have to go through this wizard. All right, so we have imported the service. So we can click on it to go to the service detail. And here are some things like the endpoint implementation on the implementation tab. You can see this is the endpoint where the service lives. We figured that out from the annotations. It knows that it's REST. We can go to the definition and see that it knows that it's a Swagger definition document, and here's the information. So we will be using that later to show the API docs. So we can go ahead and publish this now. So now we actually pushed it out to the gateway. So now this service can be approached through that red layer. So there's a new endpoint tab appeared, and that shows you what the URL of that external endpoint is. And know that the beginning of the URL starts with apiman gateway. So that's always going to be the same domain. So you have one entry point into all the services that you publish. So we can copy and paste this and hit the endpoint. Command C, yeah.
It's all Linux all the time.
Command V. There we go. Maybe automated shell scripts is the way to go. I don't know. All right, so we know it works now, right? This is not very interesting. So let's add a policy. Let's add an authentication policy. So we cannot add this to the current version because this is published to the gateway. This is like frozen in time. So we're going to have to make a new version that's going to clone the information that it currently has, so we don't have to retype all of this. And at this point, we are in version 1.1 now. So now we can add a policy. So we're going to go to the policy wizard, and let's take a basic auth. Nice and simple. Basic auth, make it required. Basic auth required. Scroll down a little bit. Yep. We don't recommend you creating static users like this. It's probably better to use a credential store, but for a demo, this works great. All right, so that's it. We have a policy now, a basic auth policy. So if we hit publish, we're going to get a new endpoint URL, right? Because now the version changed. So it's a little different endpoint. So we use this endpoint. Yeah, this endpoint will, this should now pop up a basic auth box. So that's how that works.
You render those.
Yeah.
You render those policies in any standard policy format, so that you develop your own policy format.
It's our own policy format, right?
Right, yeah, so it's our own custom format, yeah. So it's a
JSON-like?
JSON, it's all JSON, yeah.
Take one more. Yeah. Yes. Well, yeah, the service hasn't changed, right? It's the API manager policy information that has changed. No. We just pushed new policy into the gateway. So the gateway has been updated. The gateway is talking to a persistence store.
So, one more. Is there
All right,
any way,
one.
is there any way not to change the URL?
So every time a new version is released, obviously the version number changes, and so the version number has to be included as part of the request in order for us to know what version you're hitting, but it doesn't have to be part of the URL. It can be a header instead, yeah.
Okay. Well, let's make it a little bit more difficult. So we're going to set up a consumer now, right? So we're going to use the same service. We're going to change the fact that it's a public service. We're going to make it a private service. So we need to, again, make a new version. Otherwise, we can't change anything. We're going to make this version 1.2. And we're going to now go to the definition. Which one is it, Ian? You would probably know better. Yeah, here. And uncheck that it's a public service. All right. In the end, this will mean you always have to send down some kind of key so that the API manager knows who you are. So that's the API key. All right. So let's add a couple plans. So we're going to add two different plans. We're going to make a gold plan and a silver plan. Gold plan is obviously the best plan there is. And we're going to add a rate limiting policy. So for the gold plan, we're going to allow 5 requests, I think, right? Otherwise, it's going to take a lot of clicking on our part. Per application, per minute. So it allows 5 clicks, and then it says, you used up your clicks, you got to wait another minute. Okay, we're going to lock this plan. Cool, that's locked in. And we're going to go make another plan, silver plan, not as good, obviously. How about two clicks? Does that sound reasonable? Two clicks per application per minute. Very good. All right, we're going to lock this plan too. And now we're going to go back to our service and we can publish it. We still have a basic auth policy as well. So you can attach policies at the service level and at the application level. This is the version of the policy. So of the plan, yeah. So you can change the plan. And what we can then do, we will know who all our users are, and we can notify them and say, hey, the plan changed. Do you want to use the new plan, or you want to keep on the older one? All right, so now we have to go back up and create an application. An application is the thing that's going to consume our service. This is the cool part. So we're going to do make a little application. Yeah. This application is a user, right? And so this user is going to assign an API key. And the API key needs to be sent in either in a header or on the URL each time you make a request. And that's how the gateway knows what kind of user you are.
How does it identify the resource? Is it just RESTful, or do you look at a SOAP designation for a resource?
So the question was, how does it identify the resource? And the moment supports pretty much REST only. We do have plans to support SOAP, so we can pull that kind of information out of the SOAP envelope. But at the moment, we just pass everything through. So a request comes into the gateway, and the URL to the gateway has to include, at the very least, the organization ID and the service ID that's being invoked, right? And then the version is either part of the URL or it's a header. So we've established that. Anything after that, sort of your sub-resource path, just gets proxied as is back to the back-end API. Does that answer your question?
Yeah.
Maybe? Okay.
All right. So we're gonna go search for a service to consume. That's going to be fairly easy because we have only one service. But it finds, well, I actually had 2 because I prepared one before to make sure that it was working. Here we have, this is what the application can now consume, right? And this will be the screen where he or she goes to like start consuming their service. And there's a little cool link here, view service definition. This is the API documentation. So if you can open it up, you can see all the REST invocations you can make into this service. So this is a Swagger based on the Swagger doc. So this is great for an application consumer to have this information right here. And so this will all be in the API management tool. So all your APIs will be documented in this one tool, in this central tool.
Is the front end skippable?
Yeah, you can make as many pods as you want, right? Is that what you mean?
So I think
scalable.
Front end of screen.
Yeah, you were asking if the user interface itself is skinnable or brandable for your own.
Skinnable.
Yeah.
Sorry.
So at the moment, the upstream project, the answer is no. But we are in the process of working on a developer portal, which would take only sort of the consumer portions of this tool, of this user interface, and make that a standalone and brandable and skinnable deployment. So you could have a user interface just for external developers to come in, register with it, and then consume the APIs. So,
All right,
so coming in the future.
So let's say you're going to have your app be used by an end user, right? And one of the end users is willing to shell out some serious money. So we're gonna give him the gold plan, which means that we're going to set up a contract here between the consumer and producer with the various versions of the plan, and we can go ahead and register this, I think. So this means that this application is now registered. So we can use this app. So this app now can use this endpoint with this API key. So that's actually a little helpful wizard here. You can copy out a test URL with that API key right on it. If you don't want to send it in on a URL, you can send it in as a header as well. All right, let's go ahead and hit this 5 times. And I think we're already, yeah, go ahead. There we go. So after 5 clicks, it said you exceeded your rate limit. And it says, by the way, you need to wait 14 more seconds before the next minute goes in. Yes. It's a different key. Yeah. You still, because we defined a basic auth, we still need to do basic authentication. It's just that this browser was already authenticated, so it didn't pop a box.
So
Most times when you send your API, you also your username
Yep.
and password.
You can do it that way too. If that's what you want to do, you can do it that way too. Across data centers, I'm not quite sure, but across instances, we use a common storage in the back end. So if you do a rate limiting policy, it talks to that storage, that central storage.
So basically, Kurt's right. What we do for both configuration and for some of the other components like rate limiting is have a shared data store. So all instances of the gateway can communicate with the same data store, and that's how it shares data. For cross data centers and stuff, we might need to give that some extra thought. Fortunately, it is all pluggable as well, so it's very easy for us to pop in new implementations of, for example, the registry, which is the component that the gateways use to store and retrieve policy information. So, over time, we'll have to develop new versions of that to go against different data stores, MongoDB or Redis or just a JPA data source or something. So, that's a good question, though. Noted. No MongoDB. No UDDI, no MongoDB. I'm taking notes, so we're good.
Elasticsearch, right? All right, so I think we can do the silver plan, but I think you get the gist of it, and we're close to. One more question?
I was wondering if there's any concurrency in your rate limiting or shared state concurrency in your plan.
Yeah, so another good question, actually, and that's another reason why we made everything so pluggable. So a lot of the components that back some of these policies are, again, they're just interfaces, and we can plug different versions in. The current version that we have, for example, the thing that's running right now is Elasticsearch, so we store stuff in Elasticsearch, which isn't going to be very great for concurrency, so you might go a little over, right? So let's say you set your rate limit to 500 requests per whatever minute. You might end up getting 502, 503, right? For some users, that's fine, right? Because you're looking for performance over transactionality, for example. For other users, it won't be fine, and so a new implementation would have to be built that's doing something that's maybe a little bit slower, but maybe has better guarantees for data integrity.
All right, if you have any more questions, please come see us after. Also, you can find us with these coordinates. Thank you.